3, 2, 1.
Hello, everybody. Welcome to 60 Minutes to AWS Mastery. I am Daniel Brown, and I'm going to take you through this journey today. A little bit about me. So I work at Improving as a senior consultant. I'm a certified solutions architect at the professional level, a DevOps engineer, cloud migration specialist. I put that on there because that feels like all I've been doing for the last year and a half. Cutter of grass, though thank goodness the weather's turned cool, so I'm not cutting as much grass. Washer of dishes and changer of diapers. That pretty well sums it up for me. Okay, so what are we talking about today? We're talking about we're talking about art of distilling. We're talking about taking the very essence of something and extracting it out from the bulk. The earliest documented account of distilling in Scotland came from the Exchequer Rolls in 1494. The recipe of grain was given to a friar John Core to make whiskey. The Scottish monks were making this water of life, this whiskey, this in the medieval period, distilling down a fermented malted barley drink to something more refined. Unencumbered by the superfluous parts, they were left with the shining essence of a thing, something of substance, something with some bite for any of us that have had Scotch whiskey. Today, we're going to attempt to distill AWS down to the heart of what it is. Through this simplification, I pray you guys will gain a fundamental understanding that'll set you on the road to excellence and understanding. Let's take it down to the essence. Okay, so what exactly is the cloud? Okay, so we hear about the cloud. You hear about it on TV, like, oh yeah, the cloud. That if you watch the World Series, which we're in Atlanta, so we were watching the World Series, very anticipating. They talk about the AWS StatCast, and we use the cloud computing to figure out all this stuff like launch angle and how far the ball went and that kind of thing. And there's so much hype around the cloud that really we need to kind of scrape away the hype to even have a conversation about what the cloud is. What exactly is the cloud? You know what it is? It's basically just our traditional data centers with some slick marketing, some nice tools, and creative ways of billing and cost management. At the end of the day, all we're doing really, though, is we're renting computing power and storage. I mean, that's about as simple as it can get. What is the cloud? Computing power and storage. That's all it is. Okay, so AWS, though. Okay, so let's talk about AWS. All right, if you were to enter into the cloud engineering, field, or you're trying to figure out, I want to be a cloud practitioner. You go look at AWS and you see that there's over 200 products and services that are associated with AWS. Things like EC2, things like Poly, things like CodeStar. You can see a big list of them on there. I don't even know if you can read them. I had to make the resolution so small to fit all that stuff on there. Aurora, what are all these things? I'm getting into AWS and I'm already overwhelmed just reading the list of the things that are there, much less understanding what they are. How can I approach this? What's important? Can you give me some entry into it? That's what I want, is just an entry in how can I get started in the cloud without learning 200 different products and services. Okay, so I've come up with this, and this is my idea of how to get started in AWS, and there may be some people that would disagree with me, but I've distilled AWS down to five essential services. Okay, we have EC2, that's Elastic Cloud Compute, with EBS, or elastic block storage. So you could put those together. Those are almost one service, but since they have an elastic something name with it, I put it as an extra service. But basically, what is EC2? EC2 are virtual machines in the cloud. They could be Windows, they could be Linux. Heck, they could be Mac now. They have Mac virtual machines out there. They have elastic block storage out there, which is basically just like the hard drive that goes with the machine. So you have a virtual machine, you need a hard drive to boot it up, boom. That's all you need, right? So another thing they have is simple storage service, S3. That's Amazon's durable storage, and it uses a key value pair storage to store files. It's not like I wouldn't call it like a file system. You can't really query it like you could say, if you had a network drive attached to your computer, but you can upload particular files, you can download particular files. It's a good way to store files out in the cloud, and it's pretty cheap. It's a good way to store things. VPC. Okay, VPC is probably a little bit more of a nebulous thing, virtual private cloud. What is that? Well, a VPC is really just a VLAN. It's just a virtual network, that virtual local area network that's put together. So it's made up of subnets. It contains it is a certain CIDR block. It contains access control lists. It contains routing tables, basically everything network-wise that you need your virtual machines to run on. You can have private and public subnets. You can have internet gateways that allow subnets to be public, that is, so you can access them from the internet, so you could access your server. You have NAT gateways that allow, say, virtual machines that are running in a private subnet to be able to access the outside world. All that kind of stuff is wrapped up in VPC, the virtual private cloud. But if you're used to more non-weird terms, it's just a VLAN. Okay, identity and access management. So this is what I would call the final essential service. Basically, all it is it's dealing with all the permissions in AWS. Accounts, what services they have access to, ways of grouping permissions, ways of creating policies for permissions to be carried out. You had to have some kind of at least superficial understanding of IAM to be able to really make everything run. So with a virtual machine that's either a Linux or Windows or Mac, you can do practically anything, right? You could have a Apache server running on it and serving a website. You could have IIS running. You could have a database running. You could make that instance into a SQL Server Windows server instance, and you could have your database running on it. You could have Mongo running on that EC2 instance if you wanted to go non-SQL database. You could run a Redis thing and have caching in there. You could have all kinds of things in there. Basically anything. It's like giving you a blank piece of paper to write what kind of computing you want to have. And when it's backed up by durable storage, you have ways to back up those virtual machines. You have a network to run it on with VPC. Those are the critical services right there. IAM, how do you access those things? You can set up all the access. If you know those things, then that'll set you on the road to understanding how to get started in AWS. If you're getting a certification, it might be something a little different, but let's don't go into that right now. I'll talk about certifications later, maybe. Okay, so, all right, if we're going to have any discussion about AWS, let's talk about the 5 pillars of well-architected framework. This is one of those things that if you do take a certification test, you need to know these cold. Whether you're taking a practitioner certification, associate level, or professional level. At professional level, this needs to be ingrained in your soul before you take that. So the 5 pillars are operational excellence, security, reliability, performance efficiency, and cost optimization. So a lot of these pillars, I think all of these pillars share a little bit of you're responsible for one part of it, and AWS is responsible for another part of it. Operational excellence, they have these virtual machines up and running. They have SLAs that they keep. They have SLAs on the durability of storage, like what are the chances that you're going to lose a file? And it's something like 9.99999, I think like 8 or 9 something like that for S3. Probably should have looked at that before I quoted that. But let's just say that there's very little chance that you're going to lose something. And that's a lot of that's AWS. That's their ability to be reliable. The operational excellence, I guess, is probably more like, are you doing things the right way? Are you doing things the most efficient way? Using DevOps principles would probably be a good example of operational excellence. So automated builds, automated deployments, auto scaling, those kind of things would be operational excellence. I'm going to skip security for a second because it's really important. Performance efficiency, that kind of thing too, where you can scale up machines. You can build bigger machines. You can build smaller machines. You can elastically move the needle with AWS to get only exactly what you need out of AWS. You don't want to pay for something too big, and you want to, if you have something too small, then that's not going to work either because your code's not going to run. So you want to scale up to the right size. So performance efficiency, I think a lot of it's about right sizing. Let's pull out security and cost optimization and talk about it. Let's talk about security though first. Okay, so I mentioned shared responsibility a second. With security, it is always, they stress that it is a shared responsibility for security. So what does that mean? You know, what exactly are we talking about? Well, AWS is responsible for security of the cloud, and the customer is responsibility for security in the cloud. So if you have a Linux machine that's running in an AWS cloud VPC or in a subnet, and it's in a public subnet, but you have not hardened that machine against attacks, that is your problem. AWS is not responsible for you hardening that image, making it where people can't just hack in. Most of the stuff that you deploy to AWS, especially kind of right out of the box, is a little bit more open because they're trying to give you, they're trying to make it as easy as possible on you. So where you're not trying to figure out, okay, how did they set this up? How do I get into this machine? It's more open. A lot of times the security groups are just open to the whole internet. You need to know how to secure your part of it. And AWS is going to secure things like the data center. Nobody's going to go into the data center. They have armed guards. They have any structure or infrastructure that they manage themselves is secured by them. So if you had a software as a service platform, they would be securing that. Something like Lambda, you're not responsible for patching the servers that Lambda is running on, but you are responsible for patching servers that you are running in your virtual machine environment. So anyway, you're responsible for encrypting on your side. It's very important when you step into AWS to know what you're responsible for security-wise and what AWS is responsible for. So that's the shared responsibility model. Okay, let's talk about costs. I think this is one of the biggest things that bites people in AWS. Okay, so people don't know what all the things cost in AWS. So I created this chart over here, and you can find loopholes and you can find caveats to this chart. This chart is a very general summary of things. So don't say, well, actually, Daniel, with this and this, that's not quite right. Well, that's true, because AWS's pricing model, I think if you were trying to be optimistic about it, you would say that they have a very complex pricing model to keep the cost as low as possible to the end user, us. If you wanted to be very pessimistic about it, you could say that they make their costs as esoteric as possible so that they can charge people as much as they can. I tend to fall somewhere in the middle. I think probably they're doing the best they can with it, but it's so easy to be bitten with it if you do not understand how the costs are laid out. So you have to be very diligent about working through it and seeing how the costs are. So let's go through this a little bit. So generally, networking infrastructure is free. If you build a VPC, a subnet, routes, security groups, internet gateway, all that kind of stuff is free. It's just you lay it out, and the resources that run on top of it will probably be the ones that you'll pay for. One exception to the networking infrastructure being free is the NAT gateways. NAT gateways actually cost something, and it's because basically even though they're a resource in the AWS infrastructure, they're really more like a router or a device, a virtual device, and I think that's why you have to pay for them. So, right, computing. Okay, usually computing is priced by the hour. EC2, ECS, the container service, and code build, all of them get priced by how much you use hourly. So if you run a Linux box for, I don't know, a month, it might be, it might be 4 cents a day or something like that, or 10 cents an hour. I mean, 10 cents an hour, not 10 cents not 4 cents a day, but maybe 4 cents an hour, 10 cents an hour, depending on how big it is. So databases are probably one of the more tricky ones. You have a price per hour, then you have a price per gigabyte.
Oh, it looks like we lost you, David, for a second. Audio and video cut out.
Oh, did it?
There you
Okay.
go. Now you're back.
Am I back on? I
Yeah.
apologize. Okay, so I was talking about databases, and databases are usually priced by the hour and priced by the gigabyte. So you pay for the storage, but you also pay for the database engine running. And that would relate to things like RDS, to Redshift, to DynamoDB. Usually internal traffic within a VPC is free. So you don't have to pay for traffic that's running within a network. External traffic, say traffic paid going to another availability zone, that is another data center, even if it's in the same region. So you could have US East 1, that's Northern Virginia, but you have Northern Virginia A and Northern Virginia B. The traffic going between those, you may have to pay for a certain amount per gigabyte. So that's one thing to be careful about. Usually AWS and most of the cloud providers, if you send data to them, it's almost always free. Not 100%. Like I said, these are all general rules of thumb. But when you pull data out, that's usually when they charge you, because they don't want you pulling it out. They want you putting more in so you can buy more of their services. Storage. So S3, EBS, AWS backup, Elastic File Service, which is, kind of like a network drive. They're usually charged by the gigabyte. Services that build or manage services. Okay, this is interesting. So most of them are free, but you pay for underlying services. So if you were using, say, Elastic Beanstalk to build out an application, a Java application, you don't pay for Elastic Beanstalk, but you pay for, say, the EC2 instances that Elastic Beanstalk creates. Same thing with CloudFormation. You don't pay for CloudFormation to build things, but if you have CloudFormation that's putting, say, a Postgres database in RDS, then you're paying for that Postgres database. Let me go back to databases real quick, not to get too tedious on this. I've seen a lot of AWS implementations, and if you are getting ready to get on the path of implementing to AWS, pay attention to the databases. These almost always seem the most costly things in AWS that I've seen. So a SQL Server database, an Oracle database, my gosh, definitely. Even a MySQL database, if that's of a certain size, you are probably going to be paying a lot of money for those things. Just pay attention to those. That's all I'm saying. Okay, so monitoring. Monitoring is usually per item or per gigabyte. So for the things like logs, storage of logs, it's usually per gigabyte. A lot of times the logs are stored in something like S3, so you're paying per gigabyte. Sometimes it might be per item. So in things like CloudWatch, it might be like you have 1,000 entries for this amount of dollars, this amount of cents, and they'll charge you per item. So with monitoring, it's usually per space, per item, something like that, per request. Application integration is usually something like per request. So if you have SQS items go into a queue, then you're paying per bulk of items. Lambda, so if you have Lambda, which is just like a code function that's firing in the cloud, it's going to be per time you fire Lambda that you're paying for. So anyway, this is kind of an interesting way to at least start to wrap your mind around costs, because it can be confusing, definitely to start with. And there appears to be a lot of hidden costs, even though I'm sure they don't mean to be it that way, but for newbies, it can be a problem. So, okay, next level. So you say, okay, Daniel, all right, I think I can learn those 4 or 5 services that you talked about that are the basic ones. What next? Well, I have what I call the next level of services. So Lambda is one of them, very, very important. And like I said, Lambda is like a function, a code that basically you can write it in. They have a number of languages they can write it in: Node, Python. You have .NET and Java support. But that Lambda fires, and it basically does one thing, and it may just like grab some information and put it in S3, or start some other kind of service. Usually they're one-off things. CloudWatch, of course, is logging and monitoring in the cloud. Systems Manager. Systems Manager is awesome. It's a way for you to be able to access and manage your servers without logging into the servers. So you could have your servers in a private subnet, and Systems Manager, you can go in and SSH into those servers, or you can go get a Windows PowerShell command line for those servers and go in and do what you need to do, whether it be updates or something like that. And also you can patch things from Systems Manager. It's a very cool tool to use. Route 53. Route 53 is a good one. It's basically like the DNS product for AWS. If you have a website, probably you need DNS. You probably need a domain. You could put that somewhere else and point it to AWS, but why not put it all in AWS? So probably good to learn about Route 53. Elastic load balancing. I think that one's a good one. You need a load balancer, an application load balancer, a network load balancer. It's included in AWS. You can go do things with it. They work very nicely. They have things where you can attach, say, firewalls to them. You can attach a AWS WAF directly to a load balancer. So you could have a publicly pointing load balancer, have the WAF attached to it, and basically it can kind of add some protection to all your websites that you're running potentially on EC2 instances or ECS or anyway. So queue service, notification service, those are really good ones to have also. Let's see, certificate manager. ACM is a nice one if you just need a certificate for your server. Works good, works perfect. You can add the certificates to a load balancer, so you can offload all of your traffic, all of the secure traffic to the load balancer, and then just push it to your servers non-secure. So that's the way a lot of people do it. Cognito is a nice service if you need authentication, SAML, single sign-on. Cognito is a nice service to be able to use, and it has a lot of potential, and it's a lot better to use it than trying to maybe build some of your own services for authentication. Okay, I'm going to go into the next level of things, which I call derivative services. It's probably not a nice name, but let's just say that these are Amazon flavors of popular solutions. So Aurora, AWS or RDS Aurora, is kind of like the managed database service. So it's relational database service. You can get SQL Server, you can get Oracle, you can get MySQL, Postgres. You know, it's RDS is pretty good, or you can have Aurora, which is the Amazon that's even more integrated with the Amazon services, and they have two underlying flavors to it. It's MySQL and Postgres. So if you want the one that's even more integrated with Amazon, then you can go Aurora. RDS, you can choose whatever flavor you like based on what you do. CloudFormation is basically like a Terraform substitute. It's JSON or YAML based, and you can write templates and build infrastructure in the cloud. Maybe you want to use Terraform instead, but AWS has this native built one that you can use if you want to. And there are some advantages to using either one of them. Just to interject my own opinion, I prefer Terraform myself, but don't tell AWS that. So Elasticache. Elasticache is a very nice AWS managed version of Redis or Memcache. It's a really great way to just deploy out a Redis, server. I don't know if it's okay to say server because it's kind of serverless, but Elasticache is a nice thing. ECS with Fargate is kind of like, and EKS, those are kind of like the container services for AWS. And I think that if you were going to do containers in the cloud, you would be advised to use one of those instead of trying to manage a cluster of EC2 instances that have been carved up into Docker nodes or Kubernetes nodes. So those are really nice. Okay, so the derivative services, the AWS managed services. What are the advantages? Okay, it's easier to build with these, easier to maintain. Why is it easier to maintain? Because they're the one updating these services. If you had RDS SQL Server, you're not patching a SQL Server. You're not dealing with a lot of the underlying things that SQL Server usually has to deal with because Amazon is taking care of most of that. What's the disadvantages? They're more expensive and there's less control. There's a lot of things in SQL Server, for instance, that we have some of our data people, they want to try to do something and they can't get to those underlying, let's say, operating system level things because those things have been taken out of play by Amazon by managing the SQL Server instances. That could be good, that could be bad. Just depends. The cost may be cheap in the instance of CloudFormation, free. You just pay for the underlying services. Elasticache, not too expensive. Aurora, RDS, those can get expensive, so just make sure you watch the costs on those. Okay, so some of you that may be like Azure people on the call, and you say, okay, I'd like to get to know more about AWS, but I'm an Azure person and I don't really understand a lot of the AWS stuff. So I put together this map over here, and it's basically kind of shows you the translations in Azure. Okay, so EC2 is virtual machines. Auto scaling is virtual machine scale sets. Okay, so RDS is SQL database. Code deploy and code commit, and we could probably put code build in there also. I think maybe I didn't have enough room for it on that chart, or it didn't look very good. Azure DevOps would be a good would be the equivalent of those. So you see that some of the services are not one-to-one. There's many-to-one or one-to-many. CloudWatch, Application Insights, VLAN or VNet, is basically the virtual private cloud. So blob storage, S3. Anyway, it's all about the same. I mean, it's all about the same. There's slight differences in all of it, but there are many one-to-one maps. Okay, so the goal of the talk today was not to imbue you guys with mastery. Knowledge gained so cheaply can't be relied upon. Instead, the goal was to set you on a path to mastery. Seek and you will find. Ask and it will be given to you. Follow the path. Be blinded to the esoteric totality. Gain some mastery over the 4 or 5 essential services. Then start to incorporate the next level services. Your eyes will be opened. You'll start to understand. Pay attention to billing. Don't neglect security. To understand AWS, one doesn't need to know everything in AWS. I still don't know everything in AWS. There's a lot of things that are out there. And there's new services that somebody pulls up and says, oh, how about this? Never heard of that one. Understanding the rationale of the architecture and how the pieces fit together, that will set you on the path to mastery. Attempting to know everything is folly. So I've given this talk before, and I did get some pushback on the methodology that I used. And I thought the pushback was very good because it came from a very well-trusted colleague, somebody that I really respect, somebody that knows what they're talking about. And she kind of gave me the counter to what the path is. So maybe there's another path. Is there another path? Another path. Okay, so Daniel, why would we replicate the on-prem mess that we have by just lifting our virtual machines that are running in the closet in our on-premise and then putting them in AWS? Why don't we go serverless? Why don't we have everything running as Lambdas and microservices? What about containers? let's take those things and let's containerize everything. That way it'll make it easier for deployment. That way we'll cut down on dependencies. Everything that we need will be right there. Relational databases. Why would we move our Oracle instance into the cloud? Why don't we just forget Oracle and just put everything in MongoDB or DocumentDB, which is the managed version of Mongo, or DynamoDB, which is a key value pair database. Let's go NoSQL, forget SQL. Let's just get rid of it. Let's use software as a service. Let's use platform as a service. You know, infrastructure as a service, machine learning as a service. You know, okay, so I can see this approach, and I think it just really depends on the person, on the zeitgeist of the company, on the current infrastructure, and also on the willingness for a company to take risks or not take risks. How risk averse is your company? You know, and be honest with it. You know, just because it's the next coolest thing to go serverless doesn't mean it's the right thing for you necessarily. That's the kind of thing that improving, being a consultant and improving, we have to juggle all the time. We don't want to just put somebody on what's cool if it's not a right fit for them. And learning AWS, I think it's an admirable approach to say, I'm going to learn from the, you know, left from the one side and then move over back to kind of the other side. So, but I think you can't go wrong with either path, really. If you want to figure out how to build with the latest cloud infrastructure and you say, you know what, I don't need to learn how to manage AWS like a local data center, then I respect that. I think that's a good approach too. There are two paths. Which should you choose? I don't know. That's up to you. All right. Are there any questions and comments? I have my LinkedIn link up there. You guys can connect with me there also if you want to ask me any questions more private or whatever, or you know, advice on kind of how to get started or something like that. I do encourage people to get, if you are very, very interested in diving into AWS, I do encourage you guys to go get certified. Get the cloud practitioner certification. It's the basic first one. You can go and learn a whole heck of a lot of AWS. And then maybe you could go get the solutions architect or machine learning or one of the cool ones too. I encourage taking classes online to learn a little bit about this stuff too. You can go to a platform like Udemy and find certification courses. And it's really not that difficult to get in, but you know, it can just take a little bit of effort. So, Justin, are there any questions? Do you have anything?
I am not seeing any questions in the list, so I think we're good.
Okay. Excellent. Well, if there are no questions, comments, I just want to wish you the best in your AWS journey, wherever that may take you, whether you're doing it just so that your company can migrate over, or whether you want to do it to learn, improve your career, maybe improve your, you know, particular situation job-wise right now, contribute to things. Just thank you so much, and y'all have a nice day.